Question 6, another geometry problem. We've got a triangle, two parallel lines. The triangles are going to be similar, which we might use to find a length scale factor between them, but let's just put the values on the diagram so it becomes a little bit more obvious. And indeed, this is turning out to be a length scale factor question, because this third line down here, that 3 times AD, 3 times this big length here, is equal to 5 times this little length here. If we muck that around, we will get a length scale factor directly. 3AD is equal to 5AE. So therefore, AD equals 5 over 3 multiplied by AE. And that's equal to the length scale factor going from the small up to the large triangle. Just try it. AD is equal to 5 over 3 multiplied by AE, which is 2x. So this is equal to 10x over 3. So if we now start to look at this shaded area, we've got one of the distances here, because I can say that ED is equal to the whole length, which is 10x over 3 minus 2x. And that is equal to, if we put this 2 over 3, effectively this is 6 over 3, so this will melt down to be 4 over 3. And because of the length scale factor relating this length, which is the short distance of the smaller triangle, we can relate that to CD by simply multiplying it by 5 over 3. So I can say that CD is equal to x multiplied by 5 over 3. So we know this length, we know this length, and we know this length, so we can find the area of the trapezium. So area of the trapezium is equal to the average of the parallel sides. So we add them up, so it's x plus 5 over 3x, and divide them by 2, and multiply it by the distance between, which we found to be 4 over 3x. And this works out to be 8 over 3x divided by 2 multiplied by 4 over 3x, which is equal to 16 over 9x squared. I think I've probably stayed in x a bit too long, because we now need to find x, and x is easily found by applying Pythagoras to the smaller triangle. So let's get x. So I can say that 3 root 5 itself squared must be equal to x squared plus square this length, which is 4x squared. So therefore I get squaring the 3, 9, squaring the root 5, 5 is equal to, and this will be 5x squared. The 5's both cancel, and we're left with x squared is equal to 9, therefore x must be equal to 3. Rejecting the negative solution because x is a positive distance. So there we have it. So now we can go sub x is equal to 3 into the area formula, and we get, therefore, area of the trapezium is equal to 16 over 9 multiplied by 3 squared, which is 9. The 9's cancel, and we get the answer of 16, well, we're not told centimetres, so this is 16 units squared, and that's the answer.